So in this lab we are going to take a look at graphs of motion, xt graphs or position time graphs, vt graphs or velocity time graphs, at acceleration time, and ft force time graphs. In this lab you'll use the same setup as before when we're doing the Newton's second law lab. We have a rock attached to a physics cart, a force sensor also attached to the physics cart, and a motion sensor on a track. And we hold on to the hook and we push and pull the cart back and forth in front of the motion sensor, only using the hook. The objective of this lab is to show that the graphs of motion that we are studying are in fact real graphs that can be easily created by students in class. I don't want you to go through this thinking that these graphs are difficult to make. They're actually quite simple. This should be one of the easier graphs that you do in this class. So what we're doing is we're trying to copy this data over here. This is not live data. This is just data that I've done real quickly. You are going to push start button, hold on to the hook, and then you're going to try to replicate this data. Now when you look at it over here, it might not look exactly the same for a couple reasons. Maybe you did it wrong. So if you did it wrong, then you can hit experiment and delete the last run or delete all runs, and it will get rid of the stuff over here. The second reason that you may have not been able to see it is because sometimes when it does it, it puts these points in and it makes it difficult to see because it's so small. It might look like a straight line when in fact it's actually not a straight line. So what you do is you take the like this, the little cursor, and you just highlight the area that you want to see. Maybe it's a smaller area, maybe it's a little tiny area, and if you want to enlarge that, then you push this button right here, which is scale to fit, and if you click right there, it will increase the size of just the area you've selected, and it will keep it all in order for you. So you can do that on any of the graphs you want that might not be showing up correctly. You'll notice that this becomes highlighted when I highlight different portions of the graph, and that will scale to fit each one, so you can see it in more detail. So when you're done with that and you have the correct pattern, go to page 3. On page 3 it says on side 1 of your lab paper, draw the graphs on your lab worksheet, which should look something like that, and explain what is happening overall in each graph. For example, in the xt graph, which is this one up here, it starts out at around 0.25 meters and then begins moving in a positive direction. Stops at about 0.6 meters and then reverses direction and moves back in the negative direction toward 0.2 meters and repeats the process 2 more times for a total of 3 times. What has happened in the velocity time graph, if you can take us through the same process, and the acceleration time graph, and of course the force time graph as well. Just explaining what these patterns mean. Finally, we're going to do the same thing, but this time we're only going to do a small portion. So how can you do this? Physically try to do this with the cart, take it, and try to see what happens. It is related to this graph, of course, but how is it related? See if you can do it perfectly or close to as perfectly as possible, and once again just highlight the area that you want. Then go on to the next page. On this page, this is side 2 of your lab paper. It says, for this set of graphs, explain what is happening in the following time frames. So instead of looking at each graph individually, we're going to look at time frames. So this is time frame 1, and it says in time frame 1 there is no force. So there is no acceleration, and therefore the velocity stays at 0, and therefore the position also does not change. So then you have to go and explain in time frame 2. It might be good to start off with the forces, time frame 2, time frame 2, time frame 2, time frame 2. Time frame 3 is in the middle right there, time frame 3, time frame 4, and then time frame 5. Trying to explain what happens in each time frame, and so we can find out specifically what's happening with each one of these shapes. So give it your best shot. Hopefully this shows you a couple things that we can very easily repeat this process in real life, and also that acceleration very oftentimes isn't a straight line, but it is curves in real life, and that means it fluctuates a little bit and you end up getting curves instead of all straight lines. So anyways, give it your best shot and hopefully it makes sense to you.